idea in chemistry that looks at quantities of substances. Mole is a very central concept. You can see that there's mole island here in the middle. So this is where we have 1 mole. Well, what is 1 mole equal to? A mole is equal to a certain number of grams, and this is from the periodic table. For volume, if it's a gas, specifically at STP, it is equal to 22.4 liters. And particles are those really tiny things. We're talking about the submicroscopic level, and we talk about Avogadro's number. This is a number of particles. Now, the reason that we're talking about particles is because I'm trying to be a little bit vague, because it might be a different type of particle depending on the type of substance that we're looking at. All right, so particles could be atoms, molecules, formula units, lots of different things. We're going to look at some examples right here in this example worksheet. You don't have this worksheet, you can just follow along with me. So we are given that there are 7 moles of a substance. This one right here, 7 moles. And we want to convert it into molecules. I know that 1 mole equals 6.022 times 10 to the 23rd molecules. And so I'm just going to do a conversion here. You put your given in the top left-hand corner. Moles can be abbreviated MOL. And then sub C6H12O6. Now we know here 1 mole of any substance has this many particles. It's the decimal there. Sometimes for convenience I write molecule MOLEC. And then moles will cancel out. And when you multiply this, 7 times 6.022 times 10 to the 23rd is equal to 4.22. That gives me 3 sig figs. Avogadro's number here has 4, but my given only has 3, so I'll keep it at 3 sig figs. And that's times 10 to the 24th molecules. So there's my final answer for that first example. Next, the mass in grams of about 400 moles of SO2. 1 mole of SO2 has a mass of so many grams. In order to determine this, I'd have to actually look at the periodic table. So for sulfur and oxygen, sulfur's mass is 32.1 and oxygen is 16. And there's just 1 sulfur, but there are 2 oxygens. So I'm going to add these all up. So 32.1 plus 2 oxygens is 64.1 grams. And that's the mass of, 64.1, the mass of 1 mole of SO2. So now we have 400 moles of SO2. 1 mole, I put mole on the bottom, so it will cancel out with the moles that are given, is 64.1 grams. So moles cancel, and 400 times 64.1 is around 25,000. Now this is about 400 moles, so this only has 1 significant figure. This number has 3 sig figs. We don't worry about this, is exact for 1. So I'm getting 25,640 grams. Now how should I round this? I really can only have 1 significant figure. So the 5 rounds that 2 up to 3. So it'll be 30,000 grams approximately. All right, another example here. I'm going to talk about, in this one, how many moles are in 34.7 grams of lithium phosphate. Well, lithium phosphate, lithium is +1. phosphate is PO4. It's got a -3 charge. And when you put these together, we're going to find the compound formula. It's a review of nomenclature. So I would need 3 lithium to balance out the -3 charge. So there's our formula. What we want to know is when you have 1 mole of this compound, how many grams is that? And you have to add them all up. So lithium, phosphorus, and oxygen. Lithium has a mass of 6.94. Phosphorus has a mass of 30.97. And oxygen is 16. And lithium, we have 3 of them, and 1 or phosphorus, excuse me, and 4 oxygens. So we need to add up all of these examples. Let's see, 6.94 times 3 plus 30.97. And then we want to add in there those oxygens. So I get 115.79 grams per mole. And I'll write that up here again. 115.79. All right. We know that we have 34.7 grams given. We want to convert to moles, so we had to put grams in the bottom, moles will go in the top, and 1 mole is 115.79. Grams will cancel, so it's 34.7 divided by 115.79, and we get 0.29960 moles. All right, for sig figs, here we have 3, here we have 5, so we can keep 3 significant figures, the first 3 digits. What is that? 6 due to that 9, rounds it up. So it ends up being 0.300 moles. All right, so here we have an example where we're given a certain number of molecules. We want to convert it into moles. And we know that 1 mole is equal to Avogadro's number. So here's our given, 5.04 times 10 to the 24 molecules. We want to convert this to moles. So I'm going to put molecules in the bottom and moles in the top. And so it's 1 mole is equal to this number, Avogadro's number. Molecules cancels out. Now when you put this into your calculator, I want you to use that EE function on your calculator. So 5.04, then you hit the second button, and then the key above the 7 has EE above it. You divide that by Avogadro's number, 6.02 EE23, and you get 8.37, and we have 3 sig figs here for this answer. So there's the answer for this example. It says how many total atoms are present in this sample. Well, if I have this many molecules, and this is of CO2, there's 1 carbon and 2 oxygen. So there's 3 atoms in CO2. So that would mean that if I have 5.04 molecules, or I'm sorry, gotta erase that part of it, 5.04, and I need to say times 10 to the 24th. Molecules, there in 1 molecule are 3 atoms. So basically I'm just tripling that number. 5.04 times 10 to the 24th times 3 is equal to 1.51 times 10 to the 25th atoms. So it's triple because there's 3 individual atoms in 1 molecule. Next, we have an example that relates to the previous one, and it says Next, how many grams does a sample weigh? So we already said that it was 8.37 moles was our answer from the previous slide, because this is the same as before. Now we want to convert this to grams. So if it's 8.37 moles of CO2, we want moles in the bottom, we want to convert it to grams. So how many grams does 1 mole weigh? Well, carbon dioxide, I have 1 carbon, which is 12 grams, and oxygen is 16 grams, and there are 2 of them. So you'll add those up and you're going to get 44 grams per mole. So now it's 44 grams in 1 mole. Moles cancels out. You take 8.37 times 44. And we can have 3 sig figs in our answer, and so that's equal to 368 grams of CO2. We'll do one last example here. It says we have 55 grams of sodium carbonate, convert to moles. Sodium carbonate, we have sodium positive 1, carbonate is negative 2, so the formula is Na2CO3. So sodium, carbon, and oxygen. I need to find the mass of this because this question is referring to grams in the beginning. Carbon is 12, oxygen 16, and for sodium there are 2. Carbon just 1, and oxygen there are 3. So go ahead and add up all of those. So sodium plus carbon plus oxygen equals 106 grams per mole. All right, so my given is 55.3 grams. Grams go on the bottom and moles on the top so that grams can cancel. We know that 1 mole is 106 grams. So this is about half of a mole. 55.3 divided by 106 is 0.522, and that's in moles. And I know that that's my final answer because the unit is moles, and that's what we were asked to find, was moles. I hope that this helps out a little bit.